Hey guys, tonight we drift into the hidden night traffic of our galaxy, where rogue black holes wander freely, invisible and hungry. You lie back the ceiling above you, slowly giving way to a dome of stars. Your thoughts loosen like moorings, snapping one by one, and you rise slowly, gently into a weightless sea. You're floating far above Earth now, not as an astronaut, but as a sleeper, unmoored from time. The planet below spins silently. The stars don't twinkle, and the Milky Way, your galactic home, stretches like a pale, ribbony river around you. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Let me know where you're watching from and what time it is on your little patch of Earth. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You drift forward, eyes wide in the starlight, as we slip quietly into one of the most unsettling mysteries of the cosmos: rogue black holes. These are black holes, not bound to any star, galaxy, or orbit. They roam the universe freely, like dark wanderers, massive, silent, and unseen. They don't shine. They don't glow. They don't shout their presence like quasars or flare with the drama of supernovae. They just drift, slowly, eternally, through the galaxy, and sometimes through ours. You probably won't survive a direct encounter, not because it would suck you in like some sci-fi vacuum, but because you wouldn't even see it coming. One moment you're basking in the warmth of the sun, and the next the solar system bends ever so slightly, just enough for Earth's orbit to decay, or Neptune to disappear, or your night sky to subtly shift forever. It's not personal. Rogue black holes don't hunt. They simply move like forgotten gods drifting through their old temples. And the galaxy is full of them. Estimates vary, but some scientists believe there may be tens of millions of stellar mass black holes in the Milky Way alone. Most are nestled in orbits around stars. But some were thrown loose, ejected, abandoned, set free by violent cosmic events. They wander now, like marbles rolled across a floor of stars. You float past a spiral arm of the Milky Way. To the naked eye, it's dazzling, populated by bright hot stars, clustered like candlelight. But your vision begins to adjust. You begin to see the space between, the quiet gaps, the shadows that shouldn't be there. That's where they drift, the dark wanderers. Rogue black holes are cosmic leftovers most often born from supernovae, the violent deaths of massive stars. But not every black hole settles into place. Sometimes the explosion kicks it so hard it flies away from its birth site at hundreds of kilometers per second. A lonely traveler with a gravitational appetite and nowhere to go. Some rogue black holes might even come from other galaxies. Intergalactic orphans flung across the void by galaxy mergers or gravitational duels, slowly drifting into the Milky Way over billions of years. They cross the border without paperwork, and they never leave. But here's where it gets interesting. Most black holes don't announce themselves. They're discovered only when they interact with matter, usually by feeding on a nearby star or heating up a surrounding disk of gas. Rogue black holes have no such dinner companions. They are the ultimate stealth travelers. Imagine trying to find a single drop of ink in the Pacific Ocean while blindfolded. Now imagine the ink is also silent, weightless, and moving. That's the search for rogue black holes. And yet, we're beginning to find them, or at least their effects. Just a few years ago, astronomers caught a suspicious flicker in a distant star field. A single star seemed to brighten and then fade, not because it exploded, but because something invisible passed in front of it, bending its light ever so slightly. Like a magnifying glass, a lens with mass but no light. That's called gravitational microlensing. And in that moment, the universe whispered, "There's something there." Was it a rogue black hole? Possibly. The calculations suggest it was heavy, too heavy to be a planet or brown dwarf, yet invisible to every telescope trained on that region. A ghost moving through space, tugging at the light as it passed. You glide now near the region of that detection. There's nothing to see, just a black patch among stars. But space itself here feels curved, like standing on a trampoline next to something very heavy that you can't see. The stars behind it dance oddly. The air, or what your mind interprets as air, feels denser. It's here you realize we don't know how many of these travelers are out there. We can't, because we've only just begun to develop the tools to even suspect their existence. Physicists still aren't sure whether most stellar mass black holes are visible because they accrete matter, or whether most of them don't and are simply lost to observation. It's a bit like wondering whether most animals in the forest are quiet because they're not there, or because they're watching you silently. Of course, all of this might sound terrifying. You, a tiny earthbound life form, spinning inside a solar system that might, statistically speaking, one day encounter an invisible gravitational monster, the size of a city, moving silently at hundreds of kilometers per second. But don't worry. Statistically, you're more likely to be hit by a falling coconut while winning the lottery and being struck by lightning. Twice. Still, someone has to win the cosmic lottery. And if it ever happens, we'll only know after the fact, when a strange wobble in a planet's orbit shows up in the data, or when a star that should be there just isn't. But we're getting ahead of ourselves. Tonight you're just drifting, watching, listening to the galaxy breathe. Somewhere out there, a black hole is wandering past a nebula, pulling at the gas clouds ever so slightly. Not feeding, just nudging, the way a whale moves through a plankton bloom. Graceful, uncaring, massive, and it doesn't know you exist. But now you know it does. You trace how stars, planets, and even black holes get flung across the cosmos in high-stakes gravitational games. You drift deeper into the plane of the galaxy, now watching from above as the Milky Way rotates like a slow-burning wheel of light. From this vantage point, everything seems calm, majestic even. Spiraling arms shimmer with billions of stars, dust lanes curve like soft charcoal strokes on an ancient canvas. But zoom in, and you'll find the motion isn't so graceful. It's chaos masquerading as order. You find yourself near a dense stellar cluster, an ancient, tightly packed ball of stars, thousands of them squeezed into a space barely 100 light-years wide. The gravitational field here is wild. Every star tugs on every other star. Orbits wobble. Close encounters are frequent. It's like a galactic arcade, except the pool balls are stars, and every shot rewrites someone's destiny. A small red star swings past a larger blue one at close range. Their gravity grabs at each other in a temporary embrace, but it's not romantic. It's orbital jousting. The red star gets flung like a marble off a trampoline hurled out of the cluster at breakneck speed. Not into safety, but into the dark. This, you realize, is how things get ejected. Not just stars, planets, brown dwarfs, even black holes. When multiple massive objects interact gravitationally, strange things happen. Energy gets exchanged, orbits collapse, and sometimes the smallest or unluckiest member of the dance is yeeted into deep space permanently. Welcome to the game of gravitational billiards. The mechanics of it are straightforward, at least on paper. In three-body interactions, where three massive objects get too close, one often gets tossed out. It's a law written not in stone, but in math and probability. And it doesn't take much to trigger it. A passing star, a lopsided orbit, or even the gentle tidal pull of the galaxy itself can be enough to turn stability into exile. In fact, astronomers believe that many rogue objects, stars, black holes, even planets, were once part of cozy, stable systems. Until they weren't. Take planets, for example. We've found dozens of rogue planets floating freely through interstellar space, completely untethered from any star. How did they get there? Some probably formed in isolation, but many were likely ejected by bigger siblings during the chaotic early days of planetary formation. Now imagine that same principle but scaled up. Replace the rogue planet with a black hole. One that was part of a binary system, two stars orbiting each other closely, intimately for millions of years. Then one of them explodes. The supernova doesn't just kill the star, it wrecks the balance. The blast sends the remaining core, now a black hole, flying off like a bullet. No more cozy orbit, no more companion. just the cold, straight path of a newly minted rogue. And there's more than one way to get kicked out. Some black holes are born in triple-star systems. When the third wheel finally overstays its welcome gravity boots, it out. It's not personal, it's just physics. Tidy little cosmic divorces that leave one partner spiraling alone and the other hurtling through space with no forwarding address. Fringe theory alert. There's even the idea that some black holes might be primordial, formed not from stars, but from ultra-dense regions of space during the Big Bang itself. If that's true, these black holes never had homes. They never orbited a star, never knew the comfort of a galactic cluster. They've always been wandering, ancient, nearly invisible, and possibly the oldest things in the entire universe. A bit like that mystery smell in your grandma's attic, only with more gravity. You drift past the edge of a globular cluster now. One last flickering star zips past you, escaping the cluster's grip after billions of years. You follow it briefly, just to see how far it will go. The answer, very, very far. There's nothing stopping it. No air, no friction, no border to the galaxy that says, sorry, you've gone too far. That's how things drift. Black holes are especially good at this. Why? Because they're heavy, dense, and stubborn. Once something gives them a push, they just keep going. Like the world's most terrifying bowling ball. Some simulations show that rogue black holes once freed can spend billions of years orbiting the galaxy in strange, lonely paths. Not quite circular, not quite stable, just long, slow ellipses through the galactic halo and back again. Some of them may even loop in and out of the disk, diving through the densest star fields, like ghosts through walls. Physicists still aren't sure how many black holes the Milky Way has launched into these wandering orbits. We know they're out there, but counting them is like trying to estimate how many invisible submarines are crossing the ocean based only on the occasional ripple. In fact, there might be black holes wandering in pairs, two black holes bound together by their mutual gravity, drifting like dark binary stars. They don't merge, they don't accrete, they just orbit each other quietly forever. Which sounds romantic until you remember they're literally holes in space-time. And sometimes they crash into each other. Those collisions release gravitational waves, ripples in the fabric of reality itself, which we can now detect on Earth. And occasionally, when scientists see one of those waves, without any corresponding light, no explosion, no flare, they wonder, were those rogue black holes? Did two invisible wanderers finally cross paths? But for now, your own path remains smooth. You float along with no threat, no rush, just watching the endless invisible games of gravitational pinball play out across the galaxy. And maybe you start to see how a universe governed by gravity alone could still be a place of chaos, drama, and unintended exiles. No villain required, just the cold laws of motion and mass playing out over time. Somewhere two stars orbit peacefully tonight. Somewhere else their third companion has already been forgotten, flung into the deep dark. And one day, someone might discover it and call it a rogue black hole. You discover how astronomers finally spotted our first confirmed rogue black hole and what it means. You float now at the edge of a vast star-filled darkness, punctured by tiny points of fire, as if someone pierced the sky with 1,000 glowing needles. Somewhere in this quiet ocean of starlight, one of the greatest cosmic mysteries quietly slipped past human attention for years. And then for a brief moment, it gave itself away. In 2022, astronomers made a tentative announcement. After years of patient observation and countless false leads, they believed they had found the first confirmed rogue black hole. Not a companion black hole spinning around a bright star. Not a galactic core monster roaring with X-rays. Just a silent traveler drifting alone and bending light as it passed. It wasn't spotted directly, black holes never are, but its presence was betrayed through one of nature's most delicate tricks, gravitational microlensing. You turn your attention to the scene where it happened some 5,000 light-years away in the Carina Sagittarius spiral arm. There, a faint star had been quietly minding its business when suddenly it brightened. Not because it flared, but because something massive passed in front of it, something completely invisible. That something bent the star's light just enough to magnify it. For a while, the star appeared dozens of times brighter, as if seen through a strange, moving lens. Then, as the invisible object continued its journey, the brightness faded and the star returned to normal. Astronomers had been watching. NASA's Hubble Space Telescope, along with ground-based surveys, tracked the light curve how quickly the star brightened and dimmed. From that, and from the subtle shift in the star's apparent position, called astrometric microlensing, scientists could estimate the mass of the lensing object. And the numbers didn't lie. This wasn't a planet. It wasn't a brown dwarf. It was too heavy. Around 7 solar masses, give or take. And yet there was no light, no heat, no companion, just mass and movement. Most likely, a stellar mass black hole, alone, traveling, a rogue. You hover now where the black hole would have been during that moment of lensing. There's nothing to see, just the faint blue shimmer of background stars. But if you squint with your metaphorical eyes, you feel a tug, a ripple, like a whisper in the space-time fabric, as though the cosmos remembers the moment it bent. And here's the best part. This detection wasn't some lucky fluke. It was part of a coordinated long-term search, one that involved years of sky watching, sorting through hundreds of candidate events, and sifting out noise, false positives, and overexcited press releases. Because let's be honest, astronomy has a bit of a habit. Every time something dims or brightens mysteriously, someone yells black hole, or worse, aliens. But microlensing is subtle. It's quiet, it demands patience, and this time, the data held. The black hole, tentatively named MOA 2011 BLG 191 OGIL 2011 BLG 0462 Catchy Right, was likely moving at over 40 kilometers per second through the Milky Way. That's fast enough to cross the distance from Earth to the Moon in under 3 hours. But in cosmic terms, just a leisurely galactic stroll. Scientists debated whether it truly had zero light. Was there a faint companion they missed? Could it be a neutron star instead of a black hole? The measurements weren't perfect. Even now, there are papers arguing both sides, but the consensus is strong. This is probably our first true detection of a rogue black hole, which raises a question that astronomers both love and fear. If we found this one by sheer patience and a lucky alignment, how many more are out there? The answer is potentially staggering. Statistical models suggest there could be 100 million or more stellar mass black holes in the Milky Way. Most of them are invisible. And if even 1% are rogues, that's 1 million invisible travelers drifting silently through our galactic backyard. And yet we've confirmed just one. It's like walking into a forest, spotting a single moth fluttering past, and realizing the whole forest is probably alive with wings. You begin to feel the scale of it now, not just in numbers, but in the quiet persistence of motion. These black holes don't orbit like planets. They meander. Their paths aren't neat circles, but wide ellipses bent by passing stars and galactic tides. They don't seek. They don't hide. They just are. And here's the kicker. Rogue black holes aren't rare because they're rare. They're rare because they're hard. Hard to see, hard to prove, hard to follow. They leave almost no trail, and by the time one affects a star's light, it's already gone, like a cosmic breeze that only rustles a single leaf. But that's changing. New missions like the Nancy Grace Roman Space Telescope, set to launch in the late 2020s, will monitor millions of stars for years on end, precisely to catch more microlensing events. It will have the sensitivity to detect hundreds, maybe thousands of rogue black holes. Not by seeing them, but by watching what they do to the light around them. We're building a census of shadows, and if that doesn't sound like a job description from a fantasy novel, I don't know what does. Fringe theory sidebar. Some physicists speculate that if there are too many rogue black holes, it might suggest something strange. Perhaps they're not all from collapsed stars. Maybe some are dark matter imposters, or exotic relics of early cosmic inflation, or as one very bold paper put it, the fingerprints of quantum gravity at galactic scale. Translation. We have no idea, but doesn't it sound cool? You drift back now, watching the galaxy not as a map of stars, but as a sea of unseen forces. The black hole you followed is long gone, faded back into invisibility. But its presence remains like a tiny dent in the mattress of space. And you wonder how many more dents are out there. How many silent travelers pass through the galaxy each night, their only sin being that they don't shine, one found. Millions to go. You glide through the solar neighborhood and learn how uncomfortably close these silent wanderers might pass. You begin to sink inward now, spiraling gently from the Milky Way's luminous spiral arm toward the quiet back streets of the solar neighborhood. It's not loud here. In fact, it's deceptively peaceful. The stars are spaced far apart, giving the illusion of emptiness. The local bubble, a roughly 300 light-year-wide cavity carved by ancient supernovae, is quiet tonight. But don't let the silence fool you. You're moving through a haunted neighborhood. The solar system. Your warm, cozy planetary home is just one pebble in a quiet corner of the galaxy. And while it feels safe, statistically speaking, we're probably not alone out here. Not just in terms of life, but in terms of large, dark, incredibly dense visitors. The kind you'd never know were passing by until long after they were gone. Astronomers have a charming term for this region, the solar vicinity. It's an ever-expanding catalogue of the star's dust clouds and occasional brown dwarfs within about 100 parsecs of Earth. That's roughly 300 light-years. A gentle, manageable chunk of the galaxy. Small enough to survey, big enough to hide things. And we're hiding things. Let's start with what we do know. Around 50 black holes are currently catalogued in our wider galactic vicinity, most of them in binary systems. That means they've been discovered because their partner stars reveal their presence, usually by orbiting strangely or glowing in X-rays as material spirals into the black hole. But here's the twist. That's just the tip of the iceberg. Those are the easy ones. The invisible ones, the rogues, aren't showing up in X-ray scans. They aren't pulling on companion stars. They're just drifting. According to current estimates, there could be dozens of rogue black holes within 100 light-years of Earth. Possibly more. We don't see them, we don't hear them, and they don't light up our telescopes. But they're there like shadows in the attic. You're not quite brave enough to investigate. And yes, one could pass near Earth. Don't panic yet. Near in astronomical terms usually means closer than usual, not parking in your driveway. Even if a rogue black hole passed within a few light-years, you'd be fine. Probably. Here's a fun fact. The Oort cloud, the icy shell of comets that surrounds the solar system, is estimated to extend nearly a light-year from the Sun. If a black hole were to wander through that distant boundary, we might not notice it directly. But the long-term consequences could be dramatic. A tiny gravitational nudge here, a distant comet perturbed there. The orbits of icebergs unchanged for billions of years, suddenly reawakened by a ghost. That's not science fiction, that's orbital mechanics. One black hole passing through the outer Oort cloud could destabilize cometary orbits, setting off a chain reaction of icy projectiles that slowly make their way inward, over thousands, even millions of years. Most would be harmless. Some might be dazzling. One or two might get uncomfortably close, and we'd never see it coming. But even closer passes have been modeled. In fact, in the early 2000s, a team of astrophysicists simulated what might happen if a black hole passed within 0.1 light-years of the Sun, a distance of about 600 billion miles. Far sure. But not by galactic standards. The result's tidal effects on the solar system would be noticeable. Long-period comets would be disrupted. Outer planetary orbits might stretch or shift. We're not talking doomsday, but it would definitely ruin your quiet stargazing. Closer than that, and the story gets darker. If a rogue black hole passed within the orbit of Neptune, its gravitational field could wreak havoc. Orbits would bend. Moons might be lost. Some planets might get ejected from the solar system, entirely flung into the darkness like cosmic debris. But don't worry, that's extremely unlikely. You probably won't survive it though. Okay, back to a safer distance. Let's talk about Gaia BH1, one of the more recent celebrity black holes. It's not a rogue, but it's close enough to make headlines. Located about 1/500 light-years away, it's part of a binary system. The thing is, its companion star is remarkably normal, sun-like even. But the orbit gives it away. Something heavy and dark is tugging at it. And that something is almost certainly a black hole. BH1 doesn't glow, it doesn't feed, it just orbits. And it's quiet. So quiet that for years it was mistaken for a single star system. If it weren't for the Gaia spacecraft's incredibly precise measurements, we never would have noticed. And this isn't a one-off. Astronomers expect many more similar systems will turn up as Gaia's data continues to roll in. Which begs the question, if we're only now catching loud, invisible things, how many silent ones are out there? There could be a black hole closer than Proxima Centauri, our nearest known star, and we'd never know, unless it happened to lens a star nudge a comet, or do something flashy. And most of the time, they don't. Fringe theory footnote. A few scientists have speculated that certain unusual trajectories of long-period comets, like those on extremely eccentric orbits, might hint at a massive unseen object in the outer solar system. Some think it could be a rogue planet. Others whisper, half-jokingly, maybe a black hole. The data isn't conclusive, and no object has been found. But if we do eventually discover a tiny black hole parked way out past Neptune, it wouldn't be the first time nature pulled a fast one. You coast now through the outer solar system, past the orbit of Pluto into the Kuiper Belt, and out toward the hazy nothingness where sunlight is just a memory. Every now and then, a frozen rock drifts by, slowly turning. Each one a relic from the beginning of time. You glance over your shoulder. If something were following you here, some heavy, invisible traveler you'd never know, it would cast no shadow, make no sound, just an extra mass that warps the road beneath your feet. And that's the beauty of it, and the horror. These things don't need to roar. They don't need to glow. The silence is the message. In all this emptiness, something massive could pass by, and we'd only realize it long after it had already gone. You watch how rogue black holes are born from the chaotic violence of supernovae and the strange physics of stellar kicks. The space around you begins to shift, no longer the serene emptiness of drifting dust and quiet comets. You're being drawn backwards in time to a moment before the silence, a time when light and heat and fury boiled from a dying star. The star is massive, maybe 20, 30, even 40 times the mass of your sun. It glows blue-white, bloated and unstable like a candle about to pop. Its interior burns with nuclear reactions so fierce that time itself seems reluctant to flow. You float just outside its photosphere, close enough to feel the madness beneath its skin. The radiation pressure pushes outward, gravity pulls inward, and somewhere deep in its heart the balance tips, and then collapse. In a fraction of a second, the core implodes. Protons and electrons slam together to form neutrons. Neutrinos burst outward like ghosts. The outer layers don't go gently, they rebound, erupting in a blinding detonation. A supernova. Even now your cosmic eardrums ring with the explosion's ghost. The expanding shell of gas moves outward at thousands of kilometers per second. You're hurled back by the shockwave. Stars that have hung still for millions of years now tremble at the violence. And left behind amid the wreckage in the crater of fire and radiation is the core. Crushed by gravity into something far more dense than matter should be allowed to become. Sometimes this leftover is a neutron star. Compact spinning, magnetically wild. But sometimes it collapses further, a point of no return forms, and a black hole is born. But here's the twist, these black holes don't always stay where they're born. When a massive star explodes, it doesn't go out neatly. The process is lopsided, turbulent, chaotic. Gas erupts unevenly. Neutrinos flee preferentially. And in that asymmetry, something strange happens, a kick. Physicists call it a natal kick, as if the newborn object got slapped on its backside by physics itself. And these kicks, they're powerful. Neutron stars have been observed moving at speeds up to 1,000 kilometers per second, fast enough to leave the galaxy. We know this because some are zipping through the interstellar medium, like cosmic bullets dragging glowing shockwaves behind them. Black holes are trickier, harder to measure. They don't pulse like neutron stars, so we can't trace their movement as easily. But growing evidence suggests they too receive kicks. Maybe not quite as violent, but strong enough to shove them out of their stellar nurseries. Some might leave their star clusters, others their home galaxies, and some just slightly nudged off course may drift indefinitely through the galactic disk. And voila, a rogue black hole. It's a surprisingly elegant origin story. Take a star, let it live, gloriously destroy it violently, and let gravity do the rest. But the exact physics, still a topic of heated debate. One camp argues that black holes don't get significant kicks. Their birth collapses are smoother, less explosive. The matter simply falls in too fast for chaos to develop. But another group points to high-speed black holes, like the one in the binary system, XTE J18480, hurtling through the galaxy at over 100 kilometers per second as proof that kicks do happen. The truth might lie in between. Smaller black holes might get stronger kicks. Bigger ones might form more quietly. Or maybe it depends on rotation, or magnetic fields, or something we haven't even thought of yet. Physics can be annoying like that. Now imagine this somewhere in the Milky Way. 10 million years ago, a massive star exploded. The black hole it left behind received just enough of a push to unbind it from the cluster it was in. It drifted outward unmoored. Since then, it's been wandering. And now it's passing through your neighborhood. Quietly. No fanfare. And it's not alone. Statistically, every few 100,000 years, a rogue black hole could pass within a few light years of the solar system. The odds of a direct hit tiny, but over cosmic timescales, the dice get rolled a lot. Fringe hypothesis. Some theorists have played with the idea that multiple rogue black holes might have originated from the same stellar cluster, like siblings scattered by a cosmic detonation. These families might move in similar directions, tracing invisible highways through the galaxy. If we could map their paths, we might find patterns, ripples from long-dead explosions. You're drifting now above one of these imagined paths, a corridor of space where something long ago shattered symmetry and set mass adrift. And here's something quietly fascinating. Supernova explosions don't just make rogue black holes, they also shape galaxies. The violent feedback of these events stirs interstellar gas triggers, new star formation, and redistributes heavy elements. Without them, the galaxy would be stagnant. Life as we know it wouldn't exist. So the very process that gives birth to black holes that flings them outward into roguehood is also the process that eventually leads to you. You're made from the ashes of stars, and the black holes are too, just more committed. As you hover in the fading glow of the supernova remnant, the dust begins to cool. Atoms recombine, nebulae form, and new stars, some with planets, some with future dreams of sentience, begin to ignite in the wake of death. But the black hole, it's already gone. Off on its solo journey. No gravity well to orbit, no light to anchor it, just a one-way ticket through the cosmic sea. And you follow, drifting behind it. A stowaway on a ghost ship moving deeper into the galactic dark. You explore how rogue black holes give themselves away, not with light, but with warp's lensing and the bending of reality. You continue your slow descent behind the rogue, coasting through space like a falling leaf in syrup. There's no trail, no glow, no scent or sound. Just a faint unease in the fabric of space, like the tension in a drumhead before the strike. You can't see it, but something is here. Black holes are strange like that. They don't shine, but they reveal themselves by hiding everything else. Light that passes too close bends inward, arcs around, and if unlucky, vanishes. Not in a fiery blast, not in a puff of smoke, just gone. But the universe is clever, it leaves fingerprints. The most elegant is gravitational lensing. When a massive object sits between you and a more distant light source, the light curves around it, warped by gravity. You've probably seen the dramatized version. Einstein rings those glowing halos formed when light from a background galaxy bends around a foreground mass. But in the case of a rogue black hole, it's subtler. Imagine a distant star blinking slightly brightening, then dimming like a slow cosmic wink. That's called microlensing. The rogue black hole has passed in front of the star, warping the starlight just enough to make it temporarily brighter. Then it moves on. No flash, no flare. Just a bump in the graph like a ripple on a lake. Blink and you'll miss it. Astronomers now monitor millions of stars for exactly this kind of anomaly. Telescopes like OGLE, a delightfully Tolkien-sounding acronym for Optical Gravitational Lensing Experiment, have detected hundreds of microlensing events, many of them caused by regular stars or brown dwarfs. But some are dark. They leave no visible culprit behind. That's where it gets exciting. In 2022, scientists using data from the Hubble Space Telescope and OGLE confirmed the first free-floating stellar mass black hole through microlensing alone. The event, named MOA 2011 BLG 191, OGEL 2011 BLG 0462 Catchy, right, lasted around 200 days. The background star brightened and shifted positions slightly parallax, caused by the warping of spacetime itself. And when they tried to find the lensing object, nothing. No star, no brown dwarf, just math. And the math said about 7 solar masses. Incredibly dense, completely dark. In other words, a rogue black hole. Let's pause here for a moment. Imagine standing beside that distant star light years from Earth. Everything's calm, ordinary. Then, like a whale sliding beneath a boat, something massive and invisible passes between you and the cosmos. Your light wavers. You feel gravity you can't see. And then it's gone. That's what a rogue black hole feels like. Not a scream, but a pressure. A wrongness in the alignment of things. Now, if you had the right instruments, really good instruments, you might notice something else. As the black hole drifts, it also pulls on surrounding stars. Very slightly. Over decades or centuries, those stars might change their paths. It's a quiet clue, but it's there. This is how we hope to catch more of them, not by their light, but by their footsteps in the gravity field. It's a little like tracking an invisible elephant through a snowy forest. No footprints. But the trees lean differently. The wind sounds odd. The birds are quiet. You're in that forest now. Look around, see that star over there, the one that wobbles a bit too much. It might be under the sway of something unseen. Something heavy. Something passing through. There's an old philosophical joke. If a black hole passes through the galaxy and no one sees it, does it exist? The answer, of course, is yes. It warps spacetime whether you believe in it or not. And speaking of warped spacetime, have you ever imagined what it feels like to be gravitationally lensed? You're about to find out. As you drift just ahead of the rogue black hole's path, a distant star aligns perfectly behind you. And suddenly, reality bends. Light curves around your periphery. The star seems to double, then ring. You feel stretched. Not in the painful spaghettification where you're too far from the event horizon for that. No, this is more subtle. Like being pressed gently into a new dimension. One where up and down trade places. Where the shortest path between 2 points isn't a line, it's a circle drawn on curved glass. The lens passes. The light returns to normal. And everything feels slightly different. As if you now see the universe from a slant. That's the quiet power of black holes. They don't need to shine to announce themselves. They change the shape of space, the geometry of time. Even your thoughts seem to bend slightly around them. Here's a curious idea from fringe cosmology. What if black holes are not just endpoints, but gateways? Some have speculated that a black hole could connect to a white hole, a theoretical object that ejects matter rather than swallowing it. These wormholes remain purely speculative. No evidence, no mechanism. Just the result of certain solutions in Einstein's equations that under the right conditions don't forbid such things. So it's not impossible, just unlikely. Still, if a rogue black hole passed by and you happened to drift too close just enough to touch the event horizon, you might fall in. And if the universe is feeling generous, you might come out the other side reborn in some mirror cosmos. where time runs backward and coffee never cools. You probably won't, but you might. Now back to solid science. The Vera C. Rubin Observatory, set to come online soon, will help us find many more rogue black holes. Its mission: to scan the entire visible sky every few nights, mapping changes, flickers, winks. It's perfect for spotting microlensing events. And with enough of those, we can begin building a population map, a census of black holes we never knew existed. Some born from quiet stars, some kicked from violent deaths. All wandering, all heavy, all dark. You trail behind one now still unseen. You feel its gravity brush against you like a passing current. Not enough to trap you, but enough to steer you. And that's what black holes do in the end. They steer, they reshape orbits, they curve starlight, they guide the invisible scaffolding of the cosmos, not with light, but with absence. You encounter a rogue black hole drifting through a stellar neighborhood, and watch how stars react when a dark outsider trespasses. You follow the rogue as it coasts into a new region of the galaxy, a place not empty, but softly crowded. Stars lie ahead, dozens of them scattered like glowing buoys across an invisible current. This is no star cluster, but a dense pocket in the galactic disk, a kind of celestial suburb where young stars burn blue and fast, and older ones hang back red and resigned. The black hole enters without a sound. It does not announce itself. No lights dim, no stellar alarms go off. But you feel the tension. Imagine a dinner party where everyone's laughing quietly, and then someone walks in who doesn't belong, wearing no expression, making no sound, standing perfectly still. That's the black hole. A visitor with too much gravity and not enough conversation. And yet the stars don't panic. They are, after all, stars, majestic, lazy beasts built for the long game. If they feel the approach, it's only as a whisper. Their orbits tugged slightly, their tides disturbed the smallest hint of unease in the rhythm of their fusion. You hover near a yellow dwarf, roughly solar in size. It spins slowly, its corona flickering with the occasional flare. Around it, a system of rocky planets circles obediently. One of them might even be hospitable oceans, clouds, tectonics. The black hole brushes past at a respectful distance, not close enough to disrupt orbits, but enough to introduce drift. The system begins to wobble. The outermost planet now swings wider than before. In a few million years, it might be flung free, lost to the interstellar dark. It's not dramatic. There's no explosion, just a slow, creeping influence, a gravitational shoulder bump, and it gets weirder. Remember, the black hole still carries momentum, possibly from its birth kick, possibly from gravitational slingshots in other regions. It's moving fast enough to slice through this neighborhood in mere thousands of years, which cosmically is the blink of an eye. But in that brief time, it leaves ripples, not just in space, but in timing. Pulsars, those ultra-dense, rapidly spinning neutron stars, act like galactic metronomes. Some tick with such reliability that they rival atomic clocks. If one sits nearby, the rogue's passing gravity will alter the arrival times of its pulses by milliseconds, enough to be noticed, enough to say something big just brushed past. This is how astronomers propose to detect wandering black holes indirectly, by monitoring pulsars for unexpected delays, a kind of interstellar tripwire strung across space. You drift toward one now. It's tiny, just 20 kilometers wide, but blindingly magnetic. It spins 700 times per second, sending jets of radiation in tight beams. Each time the beam sweeps past Earth, we detect a pulse tick, tick, tick. But just now, there's a delay, a quarter millisecond. The black hole has passed through the fabric of spacetime, stretching it like a rubber sheet under its mass. The pulse's signal arrives just a hair late. It's a whisper from across the void. Now let's talk danger. How close is too close? For a star system, proximity matters. If the black hole passes within a few light years, outer planets might be perturbed. If it comes within a single light year, even more chaos unfolds. Comet clouds can be stirred, orbits can deform, binary stars can break apart. Closer still, within a few thousand astronomical units, AU and the rogue can steal. Yes, steal. A passing black hole might capture a loosely bound companion, a rogue planet, a comet, even a low-mass star. It doesn't take prisoners gently, but it takes them. In fact, simulations suggest there might be black holes with captured companions, flung from their old homes, and now dragging planets or stars behind them like forgotten luggage. Some of these stolen systems may still be bound in bizarre orbits. A planet circling a black hole as both drift through the galaxy, utterly detached from any star. It's possible that right now there are worlds orbiting invisible masters, basking not in starlight, but in dark heat from accretion, radioactive decay, tidal flexing. You pass one, a gas giant, cold, dim, bruised with stripes. Its orbit is wide, slow, silent. It circles an invisible point, and from its upper clouds, the black hole is just a warped smudge of background stars. No light, no warmth, just gravity, and still, this planet holds an atmosphere, maybe even moons. Maybe deep within its core, a warm ocean never touched by starlight stirs gently in eternal night. It is not a place of life as you know it, but it is not nothing. This isn't just fiction. Some astronomers suggest that planets can survive black hole capture, especially if they're already far from their host star. And without solar radiation, such planets might be warmed internally powered by geological processes for billions of years. Imagine civilizations emerging on such a world, never seeing a sun, never knowing daylight, living entirely underground by geothermal light. Their myths wouldn't have constellations, they'd have pressure gradients. Of course, all of that is speculative, but space is patient. Back in the stellar neighborhood, the rogue continues on. Most stars won't even notice it passed. The gravitational nudge is too slight, the time too brief. But over millions of years, the neighborhood will look slightly different. Just off enough to confuse a future astronomer. And if one day a system collapses, a planet ejected, a star disrupted, it might trace its misfortune back to this moment. A stranger among stars. No name, no light. Just the invisible trail of bent orbits and shaken timing. You drift now in the wake of its passing. The stars resume their quiet lives. Planets circle. Flares dance. Time ticks. But the silence behind you feels just a little heavier. You explore why rogue black holes are nearly impossible to find, and how scientists are playing a cosmic game of detection against darkness itself. You drift deeper into the spiral arm of the galaxy, following the faint wake of the rogue black hole as it slides between denser star fields. The Milky Way from this vantage becomes something entirely different. Less a disk of light, more a jigsaw puzzle of brightness and shadow-structured chaos on a canvas of silk. Some stars sparkle clean and sharp. Others flicker behind veils of dust like campfires seen through fog. It's a crowded sky, but it offers no clues. No blinking red arrow pointing to where the rogue black hole is going. Not even a whisper. It has melted into the crowd. This is what makes them so hard to find. You can't detect what doesn't emit, reflect, or scatter light. Rogue black holes are the ultimate introverts of the cosmos. They slip through space like ghosts through a masquerade, undetectable unless they bump into someone. And they rarely do. So how do you find something that doesn't want to be found? You start with process of elimination. First, rule out everything bright. That star, not a black hole. That glowing nebula, not a black hole. That blinking pulsar, still not a black hole. Scientists sift through catalogues of sky surveys, petabytes of data, to identify regions where something gravitationally weird is happening, but there's no visible object to account for it. And yet, the sky is vast, immense. You could hide 1,000,000 rogue black holes out here and never notice unless one happened to drift in front of your telescope on a Monday afternoon, while Mercury was in retrograde and your telescope operator hadn't spilled coffee on the controls. The truth is, we might have already seen them, hundreds of times. They just looked like nothing. So we get sneaky. The new frontier in detection is about pattern watching. Microlensing, as we saw before, is one method. When a black hole crosses in front of a background star, the light from that star bends, brightens briefly, then returns to normal. If no object is seen afterward, and if the lensing event was long and strong enough, that's a good sign it was a rogue black hole. But here's the twist. Other things can cause microlensing too. Brown dwarfs, neutron stars, even ordinary stars that are too faint or far to detect with current instruments. So we're left with probabilities, statistics. Maybe. It's like watching the leaves on a tree and guessing what kind of wind is blowing, based only on how they rustle. Now imagine doing that across billions of stars. That's the job of observatories like the upcoming Nancy Grace Roman Space Telescope, designed specifically to detect microlensing events in unprecedented numbers. It will give astronomers the kind of data set they've only dreamed of, like having a time-lapse of the entire galaxy, flickering gently moment to moment. But the detection arms race doesn't end there. Other teams are working on detecting astrometric shifts, tiny wiggles in the position of stars, caused by a black hole's gravitational tug as it passes nearby. These shifts are minuscule, often measured in micro-arc seconds, like watching a flea jump on the moon from Earth. In fact, the Gaia spacecraft launched by the European Space Agency is already mapping the positions of over 1 billion stars with that level of precision. It's already found stars whose trajectories subtly deviate stars that may be dancing with invisible partners. You're floating now through one of Gaia's survey fields. Around you, stars hold their poses silent and still. But some drift, just a little, enough to make a computer raise its virtual eyebrow and say, It feels like the galaxy is playing hide and seek, but it's not a fair game. The seeker is blindfolded, the hider is invisible, and the arena is 13 billion light-years wide, and yet we keep trying. Here's an irony: you might enjoy the same black holes we struggle to detect might be some of the most common objects in the galaxy. Estimates suggest there could be 100 million rogue stellar mass black holes in the Milky Way. Maybe more. That's roughly 1 for every 300 stars. Which means, statistically speaking, as you float here, there are dozens of them nearby. You just can't see them. It's unsettling, isn't it? Not because they're malevolent, they're just physics in a cloak, but because they represent something humans aren't used to admitting. The universe is full of things we will never detect directly. Even now, cosmologists estimate that dark matter makes up about 85% of the mass in the universe, and it's still a mystery. Some have speculated controversially that a portion of dark matter could actually be composed of primordial black holes, ancient relics from the early universe. These would be different from the rogue black holes born of dying stars. They'd be much older, possibly smaller, formed just moments after the Big Bang from density fluctuations in the seething newborn cosmos. The idea is fringe, but not impossible. If it's true, it means black holes aren't just cosmic leftovers. They're fundamental, as ancient as light, as constant as time, and they're hiding in plain gravitational sight. You float now past a sector of interstellar dust where even the stars dim behind thick molecular clouds. It's quiet here, soft, almost opaque. You can't see more than a few light years in any direction. Perfect cover for a rogue. You feel watched, not by eyes but by curvature. Something nearby bends the space around you just enough to make distance feel untrustworthy. The stars seem farther, or closer. You're not sure. And that's the secret. Black holes don't hide by disappearing. They hide by bending your assumptions about space, about time, about what visible really means. It's a lesson astronomers wrestle with every day. The sky is full of things you can't see. Some of them shine too faintly. Some are obscured. And some don't shine at all but move through space like silent pinballs, rewriting star charts and redirecting comets. That's what you're chasing. A silent rewrite of the galaxy. A shadow that only makes sense by what it touches. And in the quiet of this cosmic hide and seek, you realize it's not about catching the rogue. It's about noticing what changes when it passes. You witness a rare cosmic crime, a rogue black hole caught mid-encounter with a star, and the aftermath of a gravitational theft. It begins without sound. You're drifting along a quiet lane of the galaxy where stars sit far apart and time moves like molasses in low gravity. Most of these stars are middle-aged orange dwarfs and puffed out red giants living out their final chapters in dusty isolation. And then in the distance, something jerks, a motion too sharp, too sudden. Not explosive, but surgical. A change in trajectory like a car veering slightly on ice. It's a star, alone spinning, minding its luminous business. Until now. You close in. Not too fast, you don't want to miss the details. The light from the star pulses slightly as you approach, but it's not nervousness. It's being pulled. There, off to the side. A darkness so total, it doesn't look like absence, it looks like a lie. A tear in the starfield. Space where space shouldn't be. The rogue black hole. It isn't colliding. It's not even approaching quickly. It's just there, like it's always been there, like it was waiting in that precise spot, invisible and patient. And the star, oh poor thing, it's just now realizing. You watch the star's path curve slightly. Its normal arc set for hundreds of millions of years has been hijacked. The black hole's gravity is tugging at it from afar, changing its direction degree by degree, like a cosmic pickpocket easing a wallet out of its orbit. This is what scientists call a close encounter. A gravitational brush between two massive bodies. No impact, no tidal destruction, just a delicate theft of momentum. From this distance, you can feel the tension in space itself, like stretched fabric. The black hole pulls the star into a long, slow dance, an elliptical flirtation where one partner can never see the other. This is where it gets strange. The star's brightness fluctuates, not because of internal changes, but because its light is being warped. As it swings near the rogue black hole, the intense curvature of spacetime around the black hole gravitationally lenses the starlight, bending it toward you. The result, a momentary surge in brightness, a cosmic flashbulb. To a distant observer on Earth, this would look like a microlensing event, a star growing brighter for a few days, then dimming again. Innocuous, untraceable, unless you're watching very carefully. But you're here, you get the full picture. As the black hole reels the star closer, the balance tips. There's a threshold too close and the tidal forces become lopsided. The outer layers of the star start to shift. It's subtle. Just a few solar prominences drifting out of sync. The black hole does not pounce. It waits. Always gravity, never violence. Then the envelope breaks. A stream of stellar material hydrogen-helium plasma unspools from the star's surface and flows toward the black hole like smoke caught in a vacuum. No explosion, no sound, just elegance. The star loses mass. The black hole gains a snack. This isn't total destruction. The star survives. But it's been wounded. Its shape altered its spin rate, affected its internal fusion, slightly disrupted. The black hole retreats, trailing a faint disk of glowing gas heated by friction and infall. And that disk, it shines. For the first time, the rogue is not invisible. You watch it burn. Ultraviolet X-rays, flashes of brilliance across the spectrum. For a few hours, maybe days, this rogue black hole becomes an X-ray binary, if only temporarily. To astronomers back on Earth, it might be a brief, inexplicable flare, a transient event. It might be catalogued, puzzled over, then dismissed. But you saw the whole story. You saw the theft. Here's what's fascinating. This kind of encounter isn't just theoretical. Astronomers have already detected strange X-ray outbursts with no clear companion star. Some suspect rogue black holes are to blame, drifting too close to unsuspecting stars and stealing just enough mass to light up for a moment before slipping back into invisibility. It's like catching a ghost on thermal camera just as it exhales. Now let's play out the consequences. That star, it now has a new trajectory. Its orbit is altered. Over millennia, it may drift into a different part of the galaxy, displaced by the rogue's touch. Perhaps its brightness changes. Perhaps it evolves differently, now spinning faster, fusing heavier elements. Or maybe, just maybe, it begins a new cycle of instability. Stars are stubborn, but not invincible. Even a minor mass loss can shift their internal equilibrium. The balance between gravity and radiation pressure is delicate. If the rogue took too much, the star might puff out, prematurely become a red giant early, or collapse faster than planned. In a way, the black hole is rewriting its life story, and it doesn't stop there. The gas trail left behind those glowing crumbs of plasma begin to fade, but they don't disappear. Some of it settles into a temporary accretion disk, spinning around the black hole. That disk doesn't last long, it's not being fed, but while it spins, it glows. You hover nearby, watching the disk's inner edge swirl at near-light speeds. Time dilates. Photons twist around the event horizon, some escaping, some trapped in eternal orbit. You see the famous photon ring, the last visible whisper of light around a devourer. It is hypnotic. Then silence. The disk cools. The black hole dims. The rogue slips away again, returning to shadow. You realize something eerie, that outburst you just witnessed might have been the only clue to this black hole's existence in billions of years of drifting. A few days of light, then nothing. It's as if the universe allows us a glimpse and then pulls the curtain closed. And now in the dark aftermath, the black hole carries more than it did before. A trace of stellar mass, a curl of angular momentum, the scent of light still clinging to its edges. It moves on. You linger watching the wounded star adjust, flicker, stabilize. It will carry on. It will shine again. But it will never be the same. And in some deep cosmic database, its entry now has an invisible asterisk: encountered unknown gravitational anomaly. Trajectory updated. Meanwhile, somewhere ahead, the rogue glides into another stretch of black sky, looking for its next unguarded moment. You weigh the odds, how close a rogue black hole could come to Earth, and what it would feel like if one did. The galaxy has gone quiet again. You're sailing through a region sparse with stars, a kind of celestial savanna where only the occasional sun breaks the dusk. You drift gently, weightless, with nothing ahead, but an infinite ribbon of probability. And a very human question begins to echo in your mind. What if one of these things came for us? You've watched a black hole graze a star. You've seen it bend light-slice orbit and pull matter like string from a spool. You know now how quiet it is, how undetectable. And Earth, your little blue home, is sitting in that same darkness, twirling obediently around the sun. Content, unaware. Could a rogue black hole be heading right for us? Let's crunch some cosmic numbers. Not with chalkboards and equations, just plain intuition and star sense. There are somewhere between 10 million and 100 million rogue stellar mass black holes wandering the Milky Way. That sounds like a lot. Until you remember that the Milky Way is about 100,000 light-years wide, and that it contains more than 100 billion stars. So for every one black hole, there are roughly 1,000 stars. That's like walking through a forest with 10,000 trees and knowing that maybe one of them is hollow and filled with bees. Probably not the one you're next to. Probably. In terms of Earth's safety, this means we're not in immediate danger. But immediate is a funny word on galactic timescales. Right now, the closest known black hole is about 1/500 light-years away. That's far. Even at relativistic speeds, which black holes don't usually travel at, it would take millions of years to get here. Still, space is dynamic. Stars move, systems shift, and black holes don't follow the rules. They cut across galactic lanes like a drunk bowling ball. Let's say a rogue black hole does head our way. What would happen first? You wouldn't see it. You wouldn't feel it. You wouldn't even know until your telescopes did. Maybe they'd catch a subtle lensing effect, some background star flickering oddly. Maybe the Gaia spacecraft would notice the sun's motion starting to drift by 1 microarc second. And maybe, just maybe, someone at a lonely observatory would write a paper no one wants to read. Detected parallax deviation in solar trajectory. Possible rogue mass approaching. Estimate 40,000 AU. Velocity inbound. Even then, there'd be no panic, just fascination. After all, 40,000 astronomical units is still about 0.6 light-years way beyond the edge of the Oort cloud, that mysterious bubble of icy debris loosely bound to our solar system. But as the years pass, centuries, maybe it gets closer, and its gravitational influence becomes real. You'd start to see comets behaving oddly, long-period objects diving in at weird angles. The Kuiper belt would wobble. Orbital simulations would begin to show strange predictions. And then, the black hole would enter the Oort cloud. Thousands of icy bodies dormant for eons would be jostled like marbles. Some would be flung out of the solar system, others inbound. That's the first tangible danger, a spike in long-period comets raining down on the inner planets over the next million years. A celestial storm with deep evolutionary consequences. Dinosaurs, after all, might have met their end thanks to something like this. But we're not done yet. Let's suppose this rogue black hole keeps going right toward the sun. When it reaches a few thousand AU, things get spicy. Planetary orbits begin to stretch. Not drastically at first, just enough to confuse astronomers and make astrologers rewrite their charts. Pluto might veer off its usual track. Neptune could tug slightly at Uranus. The outer solar system would slowly unravel. And finally, maybe tens of thousands of years later, it passes near enough to matter. If the rogue black hole swings by at a distance of 100 AU, about 2.5 times the orbit of Neptune, it could destabilize the solar system, not by crashing into anything. That's not its style. No, it would nudge. That's what black holes do. They nudge, pull, coax. And a well-timed nudge is all it takes. Some simulations suggest that if a black hole passed within 100 AU of the Sun, the inner planets Mercury, Venus, Earth, Mars could slowly spiral into chaotic orbits. Not instantly, not like dominoes, but over thousands, maybe millions of years, their paths would become unpredictable. Earth might drift closer to the Sun, heating up like a neglected stove coil. Or it might be ejected, entirely tossed into the interstellar dark, becoming a rogue planet, cold, unlit, but still spinning. You'd survive the passage. You'd just lose your orbit. A dry cosmic joke whispered, "Just for you. You probably won't survive this, but Earth might." Now let's go darker just for fun. What if the black hole comes closer than 1 AU, game over? If it passes between Earth and the Sun, we're dealing with gravitational chaos. Tides stretch unpredictably. The Moon's orbit warps. Earth's crust could crack from internal flexing, like a boiled egg starting to peel. And if it comes closer still, say goodbye to the atmosphere. The black hole wouldn't need to touch us. Just skimming close enough would siphon air, water, and possibly the crust atom by atom, pulling it into an invisible spiral of doom. Earth would become a dry, airless rock, a memory. But let's not get ahead of ourselves. The odds of that happening are vanishingly small, less than 1 in a trillion in any given millennium. It's the cosmic equivalent of getting hit by a single grain of rice, thrown from the other side of the Pacific Ocean, by a crab, in a tornado. Still, it's not zero. And that's what makes it fun to think about, isn't it? It's the paradox of cosmic fear. We're surrounded by slow, graceful doomsday machines that will almost certainly never notice us. Almost. So we look to the sky. We watch. We measure. We invent spacecraft like LISA, a future observatory that will detect ripples in space-time, maybe even from black holes passing by, quietly humming like ghosts in sonar. Because if one of these rogues does decide to visit, we want to know early. Not to stop it, we can't. Just to understand it. Just to see it coming. Because in a universe where so much hides in silence, even the chance to watch the end is a kind of victory. You drift past a rogue with no light, no trail, no warning, and imagine the strange physics inside its event horizon. It's out here. You don't see it. You never see it. But the sky just shifted. You were watching the stars, the same silent grid that's always held steady, guiding your path like lighthouses in vacuum. And then a star to your right, dimmed, just a little. Not like a dying bulb, more like something passed between you. No sound, no flash, just subtraction. That's your first hint. You've met rogues before, black holes tugging at stars, lighting up briefly with X-rays throwing off arcs of plasma like tormented scribbles in the void. But this one, it leaves no trace. No companion star, no jet, no accretion disk, no motion, just gravity. You float closer, instinctively quiet, as if sound could betray you in a vacuum. What lies ahead is not a thing, but the absence of everything. A shape defined by what it hides. No name, no number, no catalogue entry. A black hole so isolated that even the simulations don't bother with it. It doesn't orbit. It doesn't emit. It barely exists, mathematically, yes. Observationally, not yet. But gravitationally, it's a god. You drift until you feel the pull. Not physically, you're massless here, but in the fabric of perception. The way light bends near your edges. The way starlight seems to bow in supplication before continuing on. You're entering the influence zone, the radius where the black hole's gravity starts to dictate the shape of nearby spacetime. No alarms, just inevitability. This one is about 7 solar masses. Stellar collapse class. Its Schwarzschild radius, the size of the event horizon, is just 20 kilometers. Smaller than most cities. Yet, in that compact sphere lies more gravity than the sun could muster in 1,000 nuclear centuries. It spins. You don't see it, but physics demands it. Black holes almost always rotate. Angular momentum is conserved. When a massive star collapses, its rotation compresses into the singularity. This one spins at near the maximum, what physicists call extremal. And now you wonder what's inside. No one knows. Seriously, no one. Oh sure, the equations tell us what should happen. That at the center is a singularity, a point of infinite density and zero volume. All the laws of physics break down there. That's not metaphor. They literally return undefined values. It's where math raises its hands and says, I give up. Some theories like loop quantum gravity suggest the singularity doesn't exist, that instead space itself becomes granular, like a cosmic mesh. That gravity becomes repulsive at very small scales, and the core of the black hole is a bounce point, a bridge to a new universe. Others say it's a Planck-scale knot of geometry twisted in on itself in a way we can't yet model. A remnant of dimensions beyond the 4 we know. A string loop, a brain, fold a tear in the sheet of what is. Or, if you're feeling poetic, maybe it's just nothing waiting to become something. You ease toward the event horizon. Still, no sound, no color. The edge is not a wall, it's a concept. From this side, light still escapes. Barely. Photons that skim the horizon can flee if they're lucky. But one step closer, one photon's width inward, and that's it. The escape velocity exceeds the speed of light. No return, no signals, no information. Not even the idea of you remains. Physicists argue endlessly over what this means. One camp says information is destroyed, utterly lost, like burning a diary in a fire that erases memory. Another says information must be preserved, that somehow the universe encodes every atom's story in the Hawking radiation emitted from the edges. That's right. Even though black holes are dark, they do emit a faint mist of particles. Quantum fluctuations at the event horizon allow virtual particles to become real one falls in the other escapes. Over eons, this radiation slowly evaporates the black hole. But does it carry data? Is the whole history of what fell in somehow etched into that radiation? Nobody knows. Stephen Hawking thought yes, then no, then maybe. It's the black hole information paradox, and it's one of the great open debates in physics. The resolution might require a theory of everything quantum gravity string theory or something even stranger. You drift right up to the edge now. There's no turbulence, no roar. Just a slow bend of stars around a circle that doesn't shine. You look down into the well and feel something odd. You're not falling. You're frozen. From an outside observer's view, nothing ever crosses the event horizon. Time slows down infinitely. Objects just seem to stop red-shifted into oblivion. But from your perspective, you cross it in seconds. Smoothly. No drama. That's the cruel paradox inside the event horizon. All paths lead inward. Space becomes time. No matter how you try to move, you move toward the center, like being on a down escalator that is space itself. Now imagine, just imagine, that you could survive this, that your atoms stay together, that you somehow pass into a different domain of physics. What then? Some theorists picture a white hole on the other side, an inverse black hole where nothing can enter. and everything must exit. Others speculate about Einstein-Rosen bridges wormholes that link black holes to other points in spacetime. There's no evidence yet, but no one's returned to say otherwise. You try to picture the core, not as a singularity, but as a mirror, a place where spacetime reflects or folds or becomes elsewhere. Or maybe it's a loop, a Mobius strip of time, a closed time-like curve. That's an idea from general relativity paths through spacetime that bring you back to your own past. Not time travel in the DeLorean sense, but in the your future is your past sense. It's not even science fiction, it's just math refusing to behave. You smile softly, darkly. The universe is so elegant in its rules, until it gets tired and makes a black hole. Then it shrugs, mutters, "I don't know," and flips the board. You back away, slowly. The black hole remains nameless, not because it's secret, but because no one's ever seen it. It will drift like this for billions of years, maybe forever, unmarked, undisturbed. And you realize most of the universe is made of things we'll never touch, not just because they're far or dangerous, but because they don't want to be known. They want to stay hidden, curled in the gravity of silence. So you let it be. You turn gently and drift on. You float into the data, how we count invisible monsters, and why we're likely underestimating them by millions. You drift sideways through the spiral arms, now slipping between filaments of light and tide and stardust. The galactic plane is quiet here, but not empty. It's full of things that won't speak unless spoken to. And among those most secretive of all are the ones no telescope has ever seen, the uncounted black holes. Funny, isn't it? We've mapped billions of stars, found thousands of exoplanets, measured the microwave whisper of the Big Bang itself. And yet, when it comes to black holes, the most dramatic things in the cosmos, we're still guessing. So tonight, let's take a census. Let's try with quiet breath and borrowed math to count the uncountable. We start with what we do know. There are roughly 400 billion stars in the Milky Way, depending on how you weigh the faint ones. A large portion of these, especially those 20 to 50 times the mass of our sun, end their lives, not with a whisper, but with a gravitational mic drop. They collapse into stellar mass black holes. Statistically, about 1 in every 1,000 stars will become one. That's where the early estimates come from, somewhere between 10 million and 100 million black holes quietly haunting our galaxy. But here's the twist: we've only directly found a few dozen. Seriously. We know of about 20-30 stellar mass black holes via traditional observation. These are the ones with telltale signs like gobbling up a nearby star and emitting X-rays or tugging visibly on a companion. Everything else inferred, modeled, guessed. It's like looking at a giant school of fish in murky water and seeing only the few that nibble the bait. The rest are just shadows. You ask yourself, why are they so hard to count? And the answer, like so much in astrophysics, begins with light. Black holes emit none. They reflect none. They don't glow or sparkle or twinkle. Unless they're interacting with matter, eating it, bending it, flinging it, they're practically invisible. So astronomers get clever. They track motions. They look for stellar wobble, a technique called radial velocity, where they measure a star's spectral shift over time to detect a heavy dark partner. They map X-ray emissions. They trace gravitational microlensing events, where a black hole bends the light of a background star for a brief, exquisite moment. But all of this requires alignment, activity, luck. And rogue black holes. Wandering alone, not interacting with anything, they're invisible by definition. You float into a cloud of thought now, a spiral of probabilities and models. Some researchers believe our numbers are low by a factor of 10. Others say we haven't even scratched the surface. Why? Because black holes don't just form from big stars. Some form in clusters hidden from view. Some may result from primordial collapse, tiny ancient relics from the very early universe, seeded before stars even ignited. These primordial black holes, still hypothetical, could range from asteroid mass to mountain-sized to planetary scale. And if they exist, they'd vastly outnumber their stellar cousins. We'd be swimming in them, passing through them, Some bold theories even suggest they could explain dark matter, the missing mass that keeps galaxies spinning faster than they should. Not in the one giant black hole sense, but in the billions of tiny ones theory. No evidence for that yet, but the math isn't against it. Then there's gravitational wave astronomy, our newest window into this hidden population. Since 2015, LIGO and its sister detectors have been catching subtle ripples in spacetime from black hole mergers. Every chirp in the data tells us another two unseen giants just collided. And with each detection, the statistics grow sharper. The surprising part: some of these merging black holes are massive 30, 40, even 50 solar masses larger than many models expected. Where are they forming? Why so big? Are they the products of previous mergers? Are we seeing the birth of intermediate mass black holes, those mysterious middleweights between the stellar mass and the supermassive? The census doesn't know, but the implication is clear: the galaxy may be riddled with them. One theory suggests there are as many as 1 billion stellar mass black holes quietly meandering through the galactic disk. Most are solo travelers undetected. Others are in binary systems orbiting a visible star, but too far apart to give themselves away. You look around now, floating as though through a field of ghosts. They're here. You just can't see them. It's like walking through fog filled with statues. You don't know they're there until you crash into one. So astronomers keep inventing cleverer tools. They build VLBI arrays, networks of radio telescopes spread across continents working together to see tiny shifts in position. They plan missions like Gaia and Nancy Grace Roman to monitor stellar positions with micro-arcsecond precision. Because if a black hole tugs even slightly on a star's motion, we'll catch it eventually. Or maybe we'll find them through time-domain astronomy, by watching changes in starlight and stellar behavior over decades. Or maybe, just maybe, through the soft, haunting warble of gravitational waves, which don't need light at all. You chuckle quietly. The universe doesn't like being counted. It prefers riddles. Still, the census continues. Because every black hole we find, every silent drifting mass, is one more piece of the map. One more truth about the shape of space. About the forces that built your galaxy. About the secrets that still live in the dark. You think of Earth again. You wonder how many rogues are out there now, drifting unnoticed within a few hundred light years of home. Statistically, a few dozen. But they won't harm you. Probably. They're just passing through. Like shadows across a wall. No malice, no will. Just gravity. And the long, quiet business of being forgotten. You revisit the infamous near miss of a rogue black hole brushing past Earth's neighborhood, and how we noticed only centuries too late. You drift through a slow arc of quiet stars whispering past nebulae, blinking like scattered thoughts, and then you spot it. Not a black hole, a name. Bu 0720. You hover there a moment, letting it sink in like the cold curve of an old secret. Bu 0720 isn't a myth or a legend, it's real. A pair of stars, actually what astronomers call a binary Schultz's star and its dimmer companion. Together, they slipped past Earth around 70,000 years ago, and we didn't even know until 2015. They came close. Not end of days close, but in cosmic terms, practically a handshake. Less than a light year. Through the outer Oort cloud, that distant shell of icy debris that encircles the solar system like a forgotten halo. They came and went. No fanfare, no roaring tides, no skies split open, just a quiet pass, gravity brushing gravity. But here's the thing, had that star system carried a black hole companion, undetectable to the instruments of its time, things could have been very different. No joke. We only noticed the near pass because researchers backtracked the motion of stars tracing their paths through 3D space like astronomers playing billiards in slow motion. They ran the numbers, reconstructed the orbits, found W0720's trajectory, and realized only thousands of years after the fact that it had brushed by. You imagine that now. A rogue stellar mass black hole riding quietly alongside a dim red dwarf, slipping into our neighborhood like a tourist in the fog, not aiming for us, not seeing us, just drifting. its presence warping the orbits of distant icy bodies, comets, planetesimals, frozen relics from the formation of the Sun. A tiny gravitational nudge years in the making. Some astronomers believe W0720's flyby may have perturbed a few of those ancient objects, sent them slowly cascading inward. And who knows? Maybe some of the comets we've spotted in modern history were nudged loose by a passing shadow we never saw. It's poetic in a slightly terrifying way, because if it happened once, it could happen again. You think of how unlikely it is to catch these passes. Space is huge. These flybys take place over tens of thousands of years. The signs are faint, the motion subtle. Even with modern instruments, we're just now developing the ability to predict these encounters ahead of time, rather than reading them like old stories etched in skystone. And if a black hole was part of the story, we'd almost certainly miss it. There's one reason we might not gravitational microlensing. Remember that it's when a massive object passes directly between us and a distant star, bending the light just enough to create a temporary brightness increase, like someone briefly leaning in front of a flashlight then moving on. Black holes, especially lone ones, can do this. In fact, it's one of the only ways we might detect a rogue that's otherwise inert. And it's rare. We've caught only a few suspected events so far. One of the most recent, an object with the mass of about 7 suns, possibly a black hole, was observed microlensing a background star in 2022. For a few fleeting moments, its existence became known only through its distortion of spacetime itself. No light, no sound, just bent geometry. You smile, that's peak black hole behavior. Subtle, aloof, uninterested in spectacle. Still, W0720 lingers in your thoughts. A near miss. Too slow to see in real time. Too dark to notice until the equations told us, guys. But here's the kicker. W0720 was just one example. New simulations suggest many stars pass close to the Sun every few 100,000 years. Some even closer. And it's likely that some of those have rogue black hole companions. We simply haven't detected them yet. Which means that Earth, the comfortable blue marble, humming with podcasts and pizza and panic, has likely been ghosted by dozens of invisible titans over its lifetime. You imagine the curve of space-time gently flexing as a black hole passes through unnoticed. Gravity lingers, like perfume. You think about the Oort cloud again. So far out it barely counts as solar system. So cold and dark that time might as well nap there. And you realize it's our first line of contact. The galactic waiting room. That's where rogue black holes make their introductions. Not with fire and fury, but with a soft gravitational tap. If Earth ever does get a more serious visit, we'll know only after the fact. You glance around space, this old indifferent canvas. The stars don't blink in warning. The void doesn't offer commentary, but you begin to sense a pattern. Black holes don't come for you, they drift. You simply happen to cross their path or not. The universe isn't trying to kill you. It's just not that into you. And that might be the most reassuring thought of the night. You float onward, leaving W0720 and its ghostly what-if behind. The next rogue could already be inbound. Or it might miss us by 1,000 astronomical units. Either way, we won't see it coming. And somehow that feels honest. You consider the evidence and eerie possibility that a rogue black hole may already be haunting our stellar neighborhood. You coast along the edge of comfort now, not quite afraid, not quite curious, just balanced between questions you probably shouldn't ask and answers you'll never quite confirm. Because the moment has come, the one you've been circling around like a moth at the edge of a dark lantern. Could a rogue black hole be close to us? Not out in the galaxy, close. Not a few thousand light years away, close. But here, now. You let that question settle like space dust on a silent probe. Here's what we know. There are probably millions, possibly billions, of stellar mass black holes in the Milky Way. They form when massive stars collapse, live quiet solitary lives, and drift like marbles in a gravity bowl. They're fast, they're small, and they're dimmer than dim. Some move through star clusters. Others cruise alone through the galactic disk. and just a few might be closer than we think. Statistical models suggest that hundreds of black holes may lie within 100 parsecs of Earth. That's just over 300 light-years our local stellar neighborhood. A stroll, cosmically speaking, and among them a handful might be within 10 parsecs, 30 light-years. That's right next door in space terms. Pause for a moment. Picture your neighborhood. The way you know the homes, the trees, the dog that barks 2 blocks over. Now imagine something invisible, massive and utterly silent, drifting past the mailbox at 30 kilometers per second. The thing is, it's not that wild. In 2022, using data from the Gaia spacecraft, astronomers spotted a few candidates' dark non-luminous objects warping the motions of stars around them. They dubbed one of them Gaia BH1, a likely black hole about 1/600 light-years away. Far yes, but the method is key. Gaia tracks star motions with ridiculous precision down to fractions of a milliarcsecond, enough to see a star wiggle ever so slightly if something heavy is orbiting or influencing it. And if one of those objects is invisible, it's a good bet it's a black hole. So now astronomers are scanning the data, millions of stars looking for those wiggles, tiny orbital betrayals, the gravitational equivalent of fingerprints on a clean window. And in a few cases they've found something. Candidates, suspects, unseen. You drift deeper into thought. Maybe there's one black hole solo and sleepy, hovering within just a few dozen light-years. Not flaring, not feeding, just drifting. It wouldn't need to be especially massive. 5 or 10 solar masses would do it. That's smaller than a gas giant's orbit. You could fit it neatly within a box the size of downtown Manhattan. Except it's not in a box. It's everywhere it passes through. Warping, tugging, uncaring. If such an object existed nearby, we'd only detect it by proxy, a gravitational lensing event, a subtle star wobble, maybe even an unexpected comet trajectory flung loose from the Oort cloud, or eventually through gravitational waves if it merges with something we can listen to. But what if it never does? What if it just is? There's one idea, half poetic, half plausible, that some black holes may have passed directly through the solar system at some point in Earth's history. Think about that. Not a direct hit, just a pass. Maybe through the far outer system. Maybe even cutting through the Kuiper belt. Their passage so quiet, so brief, it left no lasting evidence we can find now. Unless you count long-period comets, or ancient extinctions. Okay, that's a stretch. Probably. But hey, if you're already lying in bed thinking about invisible monsters in space, might as well consider all the flavors. You chuckle softly. Because here's where science gets deliciously weird. There's a hypothesis still hotly debated about something called Planet 9. The idea is that some of the extreme orbits of trans-Neptunian objects can't be explained by the known planets alone. So theorists suggest a hidden world about 5 to 10 times the mass of Earth lurking far beyond Neptune. But in 2019, 2 astrophysicists from Harvard proposed a spicy alternative. What if Planet 9 isn't a planet at all? What if it's a primordial black hole? Tiny, cold, invisible, nestled deep in the outer solar system, too dark to reflect sunlight, too small to detect with infrared scans. Just sitting there, warping orbits, bending comets, minding its own ghostly business. Of course, it's speculative. We have no observational proof, but it's technically possible. And if true, well, you're already living next door to a black hole. You just haven't received its calling card yet. Still take heart. Even a nearby rogue is unlikely to pose any threat. Space is huge. Even black holes have to follow the rules of gravity. Just because they're close doesn't mean they're aimed at you. And even if one were to head our way, we'd have time. Rogue black holes don't travel at light speed. They move fast, sure, but not that fast. We'd see their influence long before impact. Star wobbles, disrupted orbits, the odd gravitational lensing of familiar constellations. In other words, we're not entirely blind, just mostly. And there's comfort in that kind of uncertainty, like sleeping through a thunderstorm that never arrives. You glance across the void again, scanning for something that doesn't glow, doesn't whisper, doesn't care. Could a rogue black hole be nearby? Maybe. But if it is, it's probably just passing through. You arrive at the cutting edge, where astronomers design clever traps to detect the undetectable and glimpse the silent travelers among us. You float now with a growing sense of reverence. There's beauty in the chase-hunting shadows, with beams of math and light. You've spent hours drifting past rogue black holes, these invisible ghosts, and now you hover near the humans trying to pin them down. So, how do you catch a creature made of nothing? Let's begin with the obvious. You can't see it. Black holes don't emit light unless they're actively feeding. Most of them don't. Rogues especially. They don't scream. They don't glow. They just pull. But pulling leaves clues. You start with microlensing, that gravitational trick of light, like watching the stars blink through the warped glass of an old window. If a black hole drifts in front of a background star, the light bends. For a few days or weeks, that star appears brighter, sharper, warped, and then it fades. Microlensing is rare. You need the perfect alignment of observer lens and source. But modern surveys like OGLE and MOA watch thousands of stars at once, waiting for that wink. And recently, it worked. In 2022, the Hubble Space Telescope confirmed one of these events. The light curve matched what you'd expect if a 7 solar mass object passed between us and a star. No light, no companion, just mass. They named it MOA 11191 OGLE 11462 because science isn't great with drama. Still, it was likely the first isolated black hole ever directly detected. Microlensing opened a door. But it's just the start. You drift toward the Gaia mission, orbiting Earth like a patient astronomer with near-infinite patience. Gaia maps the positions and motions of over 1 billion stars again and again and again. And with enough data, you can spot a star that wobbles ever so slightly. Something invisible must be pulling on it. A hidden dance partner. If it's not a star, not a planet, and not a brown dwarf, it's probably a black hole. Gaia's already yielded several candidates. The more data it gathers, the better we get at tracing gravitational footprints. Think of Gaia as the cosmic detective with a magnifying glass and a few thousand spreadsheets. Next, you peer into the future. There's Rubin Observatory, formerly LSST Legacy Survey of Space and Time. Set to go online soon, Rubin will scan the entire sky every few nights over and over. It won't just look for motion, it'll look for change. Flashes, fades, anomalies, and maybe, just maybe, a microlensing event caused by a black hole drifting across the lens of the Milky Way. Rubin will catch more of them. That's almost guaranteed. Then there's gravitational wave astronomy. You smile here, because this one's dramatic. When black holes merge, they send out ripples in space-time, literal shivers through the cosmic fabric. LIGO and Virgo have detected dozens of these events since 2015. Many come from binary black holes billions of light years away. But one day, as detectors improve, we might sense something closer. A rogue black hole colliding with a neutron star. A stellar remnant spiraling into the maw of a drifting void. Those waves would be faint, but they'd tell a story no telescope ever could. You drift deeper into the soft glow of human ingenuity. There's talk of dedicated microlensing satellites, of better infrared surveys to track faint gravitational anomalies, of using the sun as a gravitational lens itself, placing a probe far enough away to use our own star's mass to bend light from distant targets. An outrageous idea, but real. Every method is a workaround, a clever cheat, because black holes don't want to be seen and we're not wired to see what isn't there. And yet, we do. Slowly. You think of how all this began. Centuries ago, black holes were just a thought experiment, a mathematical dare. What if light couldn't escape? That was it. And now, we build machines to catch their footsteps. You pass over a quiet Earth again, wrapped in data streams and wonder. You imagine a classroom, a kid staring at a dark corner of the sky, asking her teacher, could a black hole be up there? And the teacher smiling too quickly, saying, oh no, nothing's out there. But now you know better. It's not fearsome. It's just possible. There might be one. Right now, a rogue slow and serene drifting somewhere past the Oort cloud. Or maybe nearer, invisible, kind, and we wouldn't know until it changed something. A light that bent, a path that curved, a star that wobbled in just the right way. That's the magic of it. Black holes aren't monsters, they're punctuation marks, and humanity is learning to read between the lines. You ease through one final orbit of thought. Science doesn't need all the answers to be beautiful. Sometimes the questions are the light we follow home. And now, let the stars quiet. You drift farther from the edges of thought, past the tangles of equations and the whisper of stellar winds, until even the rogue black holes begin to blur, not gone, just softened by distance. The galaxy stretches around you like a silent cathedral, each star a candle that flickers without sound. They burn patiently, waiting for nothing. Behind you, the trail of tonight's journey fades. The pulses of gravitational waves, the lensing of distant suns, the ripple of dark shapes that never glow. They dissolve one by one into the gentle hum beneath it all. You feel small, yes, but not lost, because small things float, and you are floating still. Imagine yourself now as a mote inside a snow globe of stars. No weight, no time, no questions left to hold. Just drifting slowly, spinning through a universe that hums like a lullaby played in wavelengths too long to hear. Nothing chases you here, nothing waits, not even the black holes. They're out there somewhere wandering as you wander unseen companions in the infinite dark. But tonight, they do not reach for you. They pass like ghosts through your dreams. So with your thoughts stretched thin across the cosmos, and your breath soft as comet dust, you finally let go. Of questions, of gravity, of everything. The stars blink slower, the dark deepens, and you sleep at last, not on a bed, but on the quiet curve of spacetime itself.